Algebra Lesson 3-6. We've been working on solving multi-step equations, and we're going to continue working with those multi-step equations. The only difference is now we won't always come up with an answer that's a nice fraction or an integer. So our first concept is what we would call round-off error, and it's possible that as you're working through numbers you might accidentally round a number to make it easier to deal with, but consequentially what will happen is that ends up messing up your answer in the end. You need to be very careful about any rounding that you do. I would recommend, if possible, save the rounding to the very end of the problem. Then you can round. If you round in the middle, then you're not actually taking that value throughout the rest of the problem. So round-off error catches people off guard. They're not sure why they get the wrong answer. It's because they were rounding as they were going. Now the process for solving these problems will be the same for all of them that we've been working on. We're still going to try to isolate the variable. We'll still change subtraction to plus the opposite. Now we can add 32 to both sides. Those cancel out. 26x now equals 131 divided by 26. And x equals. Now this is the part where we would round, so I'll take 131 and divide by 26, and I get 5.03846. Now if I'm asked to round to the nearest hundredth, if I want to round to the nearest hundredth, then I would round to here, and I'd have to look at the number to the right. If it's 5 or higher, it would bump this up to 4. If I'm only rounding to the tenths, I look to the next number, and that's only 3, so it would be 5.0. This is the symbol for about, and I'll say 5.04 would be my rounded approximate answer. Alright, another situation. Now I'm going to give you a little trick in this one. Because this problem has hundredths, 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 if you don't want to deal with the decimals, after you've changed this to plus the opposite, you can take the entire problem and multiply it by 100. What that will do, when we multiply by 10, the decimal moves one place to the right. We multiply by 100, and the decimal moves 2 places to the right. Now the numbers will be bigger, but we won't have to worry about the decimals, which sometimes cause people problems. But remember, it's the distributive property. So all of these pieces have to be multiplied by 100, which means these decimals are going to move 2 places to the right on each one of them. So I will now have 992x plus negative 613 equals 596 plus negative 728 x. Now like I said, the numbers are bigger, but I don't have to worry about any decimals. Now I play the shuffling game just like I would before. It looks like I want to move all my x's here, so I'm going to add 728x and add 728x. Those cancel out. That's a 0 plus 12, 17. 1720x plus negative 613 equals 596. So since the x's came left, the stuff without x's needs to go to the right. Those cancel out. And now I have 1720x equals 12. Sorry, 9 and 0, 12. 1209. Last step, divide both sides by 1720. 1209 divided by 1720, 0.70290. 0.70290. round it to the nearest hundredth, and say about 0.70. Because that 2 is not enough to bump it up 1. Save the rounding till the end. You'll notice the steps are the same. If you hadn't multiplied by 100, you could still play the shuffling game with the decimals. You just have to be careful. So one more using that concept of multiplying by tenths, plus negative, multiply the entire problem by 10. Is going to move all the decimals to the right one spot. The numbers will be a little bigger, but we won't have decimals to worry about, so we'll have 37x plus negative 25 equals 61x plus negative 122. Now the shuffling game continues, plus negative 37x. Those cancel. Negative 25 equals 61x plus negative 37x. There are 24 more positive x's, plus the negative 122. Add 122 to both sides. And that means that there are 97 more positives. Last step, divide by 24. And once again, I've got a rounding situation. 97 divided by 24, 4.041. Which means if I round to the nearest hundredth, let's go ahead and go to tenths this time. To tenths would be, well, we'll go hundreds. 4.04. That 1 is not enough to bump the 4 up. Last one. Got a little bit more to it. There's still some decimals, but there's also a parenthesis in there. Change our sign to plus negative. And I'm going to go ahead and distribute this first. So now I will have 5.3 plus 3.1x plus negative 6.2 equals 9.95. Now in this problem there's tenths, hundredths. So I can't get away with multiplying it by 10. I'm going to have to multiply the entire problem by 100. So all of it gets multiplied by 100. So there. They're all going to move over 2 places. Even though they don't need 2 places, because that's the one I need to get them all to be whole numbers, that's what I have to do. 530 plus 310x plus negative 620 equals 995. So again, larger numbers, but needs no decimals. 530 plus the negative 620, those are like parts. I don't want to start shuffling until I've simplified as much as I can. And that would come out to be negative 90 plus 310x equals 995. All I need to do now is add 90. Those cancel out. 310x equals 995 plus 90 is 1,085. And the last step, divide by 310. 1,085 divided by 310 is 3.5 exactly. No rounding necessary. So, all of these examples involve the exact same process as before, but on some of them we have the trick where we could multiply by a 10 or a 100 to cancel out the decimals, and only have to deal with whole numbers.